All right, so now comes the good stuff. Now that we have all the groundwork set up, let's actually add the implementation features for our digital bank, for this decentralized bank. So remember, the point here is that we want our investors to come in, they can deposit their tokens, and then they're staking those tokens once they're deposited, and they can receive rewards. So we need to have a function. So essentially what we need in order to do that is we need to create a function in this contract, in the smart contract, where they can deposit these tokens, and that function is going to keep track of them staking, if they've staked, if they haven't staked, and be able to react and transfer the amounts accordingly. And we're going to be transferring from, right? This is not just a basic transfer because it's a third-party transfer, since they're going to be transferring these tokens, since it's going to be transferred on behalf of them once they give the approval. So we have a few things we have to consider. We have the approval and we have the staking, what we need to be thinking about. So first and foremost, and hopefully that makes sense. If not, we're going to see it in action and it's going to make a lot more sense. But a real simple version of that is, we just need to create some functionality in the smart contract so that our customers can actually stake. They can put money into this application. And once we build out the application, we'll see these functions in action. But for now, we just have to imagine them. So let's use our imagination and create a function for depositing this staking. So I'm going to write function, and we're going to call it deposit tokens. Okay, and it's going to take an amount. So we're going to call this uint. We're going to make this public so it has visibility. And then we're going to have some logic inside this function. And this logic is essentially going to transfer our tether tokens to this contract address for staking. So knowing that this is the logic, how would we write this? So what do we want to address from this? Well, we want the tether, right? We want the tether tokens, right? And we have already imported tether here, and we've set tether to tether here. We've made it public, as well as in our constructor. So what we can do is we can say tether dot, and what are we calling? Well, we're going to call the transfer from function, right? So transfer from, and that gives us already automatically a from to and a value. But in this case, our from is actually going to be coming from the global variable here, message, right? In Solidity, and specifically it's going to be a message for contracting for the sender, so the person who's calling it. So message.sender to, and in this case we can actually use our constructor and use the this method. So we could just say address is going to be this, so that's where it's going to, and then the value. And the value we can also, and the value in this case will be what? Well, it's going to be the amount, right? That's the point of the deposit token. We need to see what the amount is. Oops. And remember, we are using Solidity, so we have to put so we need to place our semicolons accordingly. And let's actually add underscores here. And let's just, okay, so hopefully this makes a bit of sense. If not, let's just think this through together one more time. So what are we doing? Well, we're going to be staking. This is a function, a staking function. Okay, and essentially what we're doing here is we are depositing our tokens into this contract. We are transferring our tether tokens to this contract here, the Decentral Bank contract, for staking. And in order to do that, we can't use a regular transfer because this is third party. This is coming through a third party. So we're going to use the transfer from function. We get that function from tether inside our Solidity, right? We already set this all up so we can access our Solidity in our constructor. Sorry, not our Solidity, our tether contract. And if we go to our tether contract, we see that we have, just like all ERC20 tokens have a transfer from function, from address to, and the value. Okay, so it goes from an address into another address with a value. Okay, now Okay, so in order for this to work, for the staking to work, we need to be able to actually keep track of a lot of things here. One of the things we need to keep track of course, is the amount that our customers are depositing, the amount that they're staking. Okay, and we can do that actually using, again, the mapping. So using the mapping method here. So we can bring in our mapping and we can set it up to an address, and that can go to uint, and we can go public and staking balance. Okay, so now we have a key store value set up for the address, that each address is going to get their own unique integer, and we're setting it to a visibility of what the staking balance is. This way now we can actually start to keep track. So this way we can actually keep track of our staking balances as they change, right? So let's say update staking balance over here, and we're going to do this. We're going to do this by putting in staking balance. And what do we want the staking balance to come from? Well, we want it to come from the person who's using it, the contract, right? And this is going to be equal to the amount, but it also has to be the current balance that we have plus the amount, right? So we're going to do staking balance. Okay, great. So now we have an update for our staking balance. What can we add also? Well, the other things that we need to add here is whether or not they have staked, to check for that, and also to check if they are staking. So have staked and if they are staking. Those are two more things that we should be adding into our deposit tokens over here for our staking. And we can create more mapping to keep track of all this. So we can do mapping, and we're going to do address, same thing, to uint. Sorry, and this time, since we're actually checking whether or not they have, what's better to use besides an integer? Well, it would be just true or false. So we can use a bool, public, has staked, and then we can do the same thing with another Boolean and do a mapping, but to see whether they are staking. So is staked. And to keep track of all this, oops, a little equal sign here. To keep track of all this, we're going to set up an array of our stakers, essentially, so we can keep track of the addresses that way. And we do that simply by setting up an address of an array, public, and then we can just call it stakers. Don't forget the semicolons. Okay, so now that we have this set up, we can actually write. Okay, so now that we have this set up, we can actually write to check whether they have staked or not, to check whether they are staked, in fact, whether they have staked and whether they are staked. So how can we write some logic for this? Well, we want to check whether or not they have, so a really good way to do that, of course, would be with a conditional statement. So we could use if, and what we can say is we can use a bang, which stands for false, because remember, whatever we put in the if value will be true. So we can say if they haven't staked, right, if they've never staked up to this point, then what we can do is we can say to the stakers, we can push, right? And push is a method that works both in Solidity, so it's from JavaScript, that's just going to push into the array the message sender. Okay, so it's going to update. And then we want to update the staking balance after this, so we can say update staking balance. And we can do that simply by saying is staking message.sender, and this should be true. And also has staked. Should also be set to true. Okay, this is pretty robust now for depositing. For depositing, we have the really important information. We have the really important logic here where we get the information we need, such as the person who's using it to transfer, the address of the actual decentral bank, and the amount, very important. We have our mapping set up to keep track of updating our staking balance to what the new amount is going to be based on the previous amount. We also added logic so that if they haven't staked, then if they haven't staked, so that, you know, that's just extra precautionary, then we can push the new amount. And we also then update everything to true for our Booleans. For our key store Booleans, we update our staking balance. So this is really neatly laid out. Is there anything else you think that would be important to add? And I'm going to add it, but I want you to just think about it. Well, what else would be really important so that this function doesn't break down, or so that it doesn't do something wrong? What other logic should we add into this function to prevent our customers from breaking the application, let's say? All right, so pause the video and think about it. And if you come up with it, then go ahead and write it out yourself. Give it a shot based on everything we've done up to now. Okay, so hopefully you had some success and you came up with a solution. If you did not come up with a solution, don't worry about it. We're going to write it out together now. These things really take, especially if you're new to coding, you know, these things take a lot of time to develop the skills that you need to come up and have that foresight in mind. And that really just comes with practice. But what you want to do essentially here is we want to bring in another conditional statement, because there's two things that there are two things that we never want our customers to be staking, right? And that is 0. We don't actually want to add 0. We don't want any transaction to happen for 0, and anything beneath 0, right? Anything of the limit up to 0, no. That should not be there. So we want to add this into our function to make sure that doesn't happen. And we can do that in Solidity with require. So all we have to do really is write require, and we can require that the amount is going to have to be greater than 0. And we can add to this, you know, a description, and we can say the amount cannot be 0. It's not going to really be less than 0. All right, and let's go ahead like that. Let's just clean this up and let's comment it in. So pretty self-explanatory, but always good practice. Require the amount to be greater than, or require staking amount to be greater than 0. That's good. Okay, that should be pretty clear. Okay, so we've completed writing out our deposit tokens for staking essentially into the application. It's pretty much everything that we need for it to be functional and not to break down and do what we want it to be doing. But of course, we don't have that front end developed yet. We don't have a test environment. So how can we know if it really works or not? Well, we can run our Truffle tests. That's what it's there for. So in the next video, let's go ahead and run some tests to make sure, and set up some tests to check to see that this deposit function is working. Okay, great work going through this. Hopefully it's making more and more sense, and I'll see you in the next video. Okay, so back in our testing over here, back in our decentral bank test over here, excuse me, let's add some tests now to check to see that our staking is working. So we want to do tests to see that the staking is there, that we can reward for the staking. And the best way to do that is to create our own describe, to bring in our own describe hook, to bring in our own separate describe hook to do that. So we're going to get a little bit of space here and write a describe. And we're going to call this yield farming. We're going to do the same pattern as always, where we need to make sure that we are going to be fetching some promises to do this. And it essentially, we can say rewards tokens for staking. All right, and let's create a variable called result. And what do we want to check here? Well, we want to check the investor balance. So let's comment check investor balance. Okay, so we can set our result to await tether dot balance of our customer, right? So this is the overall balance. And what is the balance of our investor before we start staking, like right away, automatically? Well, if we remember back in our deployment, we are issuing technically 100 mock tether tokens to our investor. So in order for this test to pass, the result here should equal that amount, right? Because they have not staked anything yet, so they should have 100 tokens available to stake. So how do we write that out? Well, I'm going to let you give it a shot first. So go ahead, pause the video, and try to write that equivalency out. Okay, so hopefully you had some success. If you didn't, don't worry about it. Let's write this out together. We're going to bring in our assert. Same thing, assert.equal. Okay, so it's an equality test, and we want to test the result, right? And we want the result to be toString, and it should equal 100 tokens, right? So we bring in our tokens function, and we make it 100. And now we could add a note, and we can say, investor mock tether balance before staking. And we can say customer mock wallet balance before staking. Okay, so let's just go ahead and run this, see if everything's working. So we'll go to the terminal, Truffle test. Oh, okay, and we see a compile message from before, is staking message sender equals true, compilation failed. Okay, so we did not successfully compile, so I can actually go back to the Decentralized bank contract, and we see that I wrote is staking, but it's actually is staked. I see that I wrote is staking, but I didn't actually call it is staking, which is a misstaked. So maybe I should have called it is mistake. Okay, bad pun. Let's just fix this. Is staking. So now we can map through this better. And let's run the compile again and the test by just writing truffle test. Okay, and we're seeing another compilation error over here. We see that it says, what do we have? A mapping problem when it comes to if we haven't staked. So we're pushing up an array, but it says if has staked, and I think it looks like I actually forgot to add if you haven't staked from the array of message senders. So we're going to put msg.sender like this. See, that was the mistake. This is back in the Decentralized bank, decentralbank.sol, and our Decentralized bank contract. It's not if hasn't staked, nothing isn't true, right, with the bang, but it's if you have staked of the sender, the person that's calling the contract for that message. So let's save that and run it again and see, fingers crossed, hopefully we get a successful compile so that we can see the test is working. Uh-oh, looks like I made another mistake. Stakers.push. Now the push method in JavaScript, of course you want to be calling it. You don't want to be setting it up for an array. So that was just another typo mistake that I see over here. So stakers.push, see, I wrote it as an array. See, I should have done stakers.push like this. You'll see that the color actually even changes JS style, like they do the same thing in Solidity. So let's save that and send it out one more time. Truffle test. And this time, I think we're good. All right, awesome. Looks like we have compiled successfully. And now what we see is a syntax error in the testing. So we're actually running the tests. Contract is working. We've got some sort of issue here in our test. Let's take a look. Line 62, result equals await tether.balance of customer. So it says that the await isn't working potentially. So let's see what's going on with the await over here. It rewards tokens and then, oh wow. So for some reason I did this too fast. So we got to remove again this parentheses. Async needs to actually have its parentheses initiated. Okay. And then we want to close our bracket of it after we have ran our async. So that ends over here. Bracket should close over here. Let's save it like this, and let's run again and see if the testing works now. Okay, everything is passing. Awesome. So you should have everything working by now. If you're running into errors, of course, you can always just download the final project and check over the code that way and see that it's working like that. But if you're coding along, you should see everything passing up to this point. So let's finish off this video by running a few more tests to see that our staking is really working here, because now we know that our deposit function is fully working and that these tests to check the initial balance is working. So what's the next test that would make sense? Well, why don't we run a test to see what happens if we actually use 100 tokens? Can we check the staking? Can we check the staking updating? Can we actually check the functionality of depositing and staking? And we totally can. We just have to write a simulation for this and see that it works successfully. So why don't we do check staking customer? Okay. So we're going to run await. And we can actually take the deposit tokens. Wait, we're going to have to take this from the central bank. Dot deposit tokens. All right. And we want to run tokens, right, to convert it. And let's just say 100 tokens, all of it. Take the full amount, all 100 tokens that we got. We're going to stake them all. We're feeling like, hey, we're going all in over here. It's just a simulation. Tokens, 100, and we want to do it from the customer, right? Because the customer is the one who is staking this. Now, if I run this test, it's not going to work, right? Because if I run it like this, there's no allowance. If you remember, like we said, back in our deposit token here function, in order for this to work, we need to have permission. It has to pass from the message sender. The person that is doing that has to approve it. So it's not actually going to run. It's going to fail if I do it like this. So what we're going to need is the approval. And in order to get the approval to pass from the message sender, we can actually, all we have to do is run a simulation of the approval of the approve function, which we wrote, if you remember, which we wrote, if you remember, in our tether function here when we wrote the approve. So this can allow for an emission of approval from the message sender, the spender, and the amount. And we do that here by writing in await. We're going to get tether.approve. And we want to approve the same amount, tokens, 100 from investor, from customer. So you know what? From customer. And we need the address as well, right? What's the address here? Well, which is the address that we want to approve this deposit? It's the central bank address, right? Okay, so first we send out the approval. We say, hey, you can approve 100 tokens to send to the central bank address. Wait, 2 S's. Haha, I caught that in advance. From the customer. After this has been approved, then we can actually deposit these tokens to the decentral bank address from the customer. So let's go ahead and run this test, and hopefully it should work. Okay, and we see that our promise was rejected. Oh man, why were we rejected? All right, well, let's take a look back in the code here. Okay, so I see there's a syntax error where I'm closing this parentheses here. And this is why the approve wasn't working, if you noticed, because when I had it like this, let me go back. I'm essentially closing the it statement. And so it's not actually capturing what we need from Tether, doesn't understand what approve is because we never awaited for it. So if I move the parentheses underneath and I run this test again, all right, everything is passing. Excellent. Always a good thing. Means that we can move ahead. This is what testing is for. Okay, so what we've done is we've simulated here staking for the customer so that we issue 100 tokens. Here, let me add of 100 tokens from customer, and then we approve it and we await for that to happen, right? So we deposited that into the bank. So what else can we check now that we've deposited that? Well, now we should be able, well, now shouldn't we, well, now if we do that, then shouldn't the customer have nothing left because they gave everything away? So we should be able to check updated balance of customer. And essentially, it's the same thing that we would do up here, right? We're just going to send the result back. So let's just copy paste it in. And then now instead of 100 tokens, we should have 0 tokens because the customer has deposited 100. All right, so that should, okay, so that should check for that. What else can we check? Well, if the customer has 0, then shouldn't the central bank have 100? Okay, so pause the video and write the test for the decentral bank to check the decentral bank. And, you know, just a hint, it's the same thing that we've been doing, but we want the address to move towards an update of the decentral bank. Okay, good luck. All right, so hopefully you had some success. Let's go over it together. So let's check updated balance of the central bank. And we're going to do the same thing once again. Only here, what we're going to do here, I'll just copy this. Instead of the customer, what we want is the balance of the owner, right? Actually, we don't want to give the balance away of the owner. That's not right. We want specifically the decentral bank dot address. Let's just do that. That's better. And right, let me actually fix these messages. So update balance. So this should be customer. This should be mock. This could be mock wallet balance after staking. 100 tokens before staking. Let's do. Okay, fine. And this should be the central bank mock wallet balance after staking from customer. Excellent. All right, what else can we test for? Well, we could check to see that the isStaking function is working, because if you remember, the other thing is we have our Boolean. We have our Boolean over here for where is it? Over here for isStaking. So we can check isStaking because they should be staking at that point, and it should be true, right? So you can pause the video, and if you're feeling brave, go ahead and try to write the test to see that the updated status should be true. All right, hopefully you had some success. So we're just going to do this together. isStaking balance. So we want to write results, await, and we want to take it from the central bank here, and we're going to check for isStaking, and we want to see if it's staking from the customer. Okay, and let's check our equality here. Would be equal result to string, and here it's not about a number, right? Here it's just a value. So we want this value to be true. True. And we can have our notes saying that customer is staking balance to be true. Sorry, customer staking status after staking. Okay, so let's save that. That's a lot of great, smart tests to make sure that everything's working before we actually deploy on the blockchain. And so what do we just do? Let's go over it really quickly. Let's go over it briefly again. So we're doing a test to check the investor balance. We get the investor balance of the customer, right? Customer, remember, comes all the way up from here, from our contract. It is the second address in our Ganache. Where's Ganache? Over here. It's this address, right? So we get that, and then that should equal to 100 tokens, right? Before staking, because we remember in our deployment, we've got 100 tokens. We've gone over that a bunch. Hopefully that makes sense now. Then we check the staking for customers of 100 tokens. All right. So here we actually have to run an approval first, right? Because we can't actually deposit without getting the approval, because this is a transfer from, not a transfer function that we're taking. So we go to central bank deposit tokens. We have 100 tokens from the customer, okay? But in order for this to work, we have to get the approval. And so we run the approval. Basically a simulation here. We run the approve for 100 tokens first. And after we do that, then we can deposit 100 tokens from our customer into the central bank. So the customer says, hey, you can take 100 tokens. Then we run this, okay? Updated balance. All right, so after the customer has said you can take basically all our tokens, the customer should have 0 tokens left. So that's what this checks, right? And oh, here I made a mistake. the decentral bank should have 100 tokens, right? Because then after, the customer has no tokens, we check the balance of our decentral bank, and we should have received 100 tokens. So we get the balance from decentral bank address, and that should be 100. Finally, we check for our deposit token Boolean updates to true, and we run an assertion for that. And that's that final staking. And this is basically all the tests. It's really all that. I went into, hopefully, I've gone into a lot of detail to connect this for you over and over again. So hopefully it's clicking, it's coming together now. If not, don't worry about it. Just keep going with it, especially once we get the front end working. You're going to see all this in action. But let's go to our Truffle console. Just our regular console, and let's run a Truffle test. And hopefully hopefully we're in the money and things are looking good. So let's hit enter. Okay, so we've got one thing that's not working out here. Decentral bank mock wallet balance after staking from customers. So plus expect minus actual. So it was expecting something different. So let's take a look. Oh, okay, I see what's happening here. All right, we are actually getting the results to be the wrong thing here. We're sending the result to be the balance, to be the tether balance of a decentral bank address when I switch that with owner, which doesn't make a lot of sense, to be honest. So what I want to do actually is, we don't want to take it from tether. We want to see the balance from actually from the decentral bank. And we can actually do this if we grab from the decentral bank. We have staking balance, right? And we can grab the staking balance from the customer. Okay, so I can save that. And just to clarify that, if I go back to the central bank, we have our staking balance here. And our staking balance is the updated amount, right, after we're staking. Okay, you know what we're going to do? So because we want to check updated balance of the central bank, we're doing this wrong. We want to grab the balance of, right, because we want to get the balance of the decentral bank. And so we can use balance of from Tether. We can use this functionality, and we can actually grab it from the decentral bank address. We can grab it from the decentral bank dot address like this. Let's try this. Okay, so great. So all of our tests are passing. Amazing. In the next video, let's build out more functionality for issuing tokens, rewarding tokens, because this is a digital bank and people can put their money in and then they get, or people can put their crypto in and then they're going to get tokens in exchange for putting in their tokens. So let's create the reward functionality, run tests for that, and then also after that, we're going to do the unstaking so people can take their tokens out if they want and have that functionality as well. Always good to give people the choice after they put it in to take it out. Not very nice to say, hey, you put it in, sorry, it's just going to have to stay there forever, right? So we're really working under the hood here. Hopefully the dots are starting to connect. Keep on practicing, keep it up, and I'll see you in the next video. All right, so we basically have our tests working for our deposit token now, and we have the ability to deposit. Let's now create the functionality to reward and to issue tokens for people who are depositing. You know, like a bank, we want to say, we're going to do something where, let's say somebody deposits 20 tokens, they're going to get X amount back. If they deposit 40 tokens, maybe they're going to get more. We'll have an incentive. So if they deposit all their tokens, then they'll get the most amount back. If they deposit just 1 token, 2 tokens, we give them just a smaller amount back. Okay, so let's write some functionality to do that. So where would we do that? Well, if you guessed, in the decentralized bank, Solidity contract, oops, not the JSON file, then you are getting this. All right, so let's go into our contract to central bank. And if you still weren't sure where that kind of logic would go, don't worry. It takes time, and these things will start to click. So I'm going to scroll down, and we see we have our function here for the deposit token. So let's do the issue token. So issue reward rewards. All right, so we're going to create a function here called issue rewards, or issue tokens. It's fine. All right, and it's going to be visible, public. And the first thing I want to do, the very first thing we do before we issue tokens, I want to create a restriction. I don't want anybody to be able to use this function to be issuing tokens. We want to make it so that only who should be able to issue the tokens? The owner, right? Like, we should be the ones to issue the tokens. Makes sense. So let's require the owner to issue tokens only. Yeah. So we can just do that by typing in require Solidity. And what should we put in here? Well, we want the message.sender. We want the person who is in that instant calling on the contract to be the owner. The double equal sign is equal to, not to be confused with equal, which is something that equals something. This has to be the exact of what this is, which is the owner. Okay. And we can say here, we can write some kind of message. The caller must be the owner, right? Okay, great. So now we have that set up. Let's think about the actual logic. How can we do this? Well, let's just say theoretically, the way that we want to do this is that the owner can actually call this function whenever they want, depending on a schedule that they have, where based on that schedule, whatever is convenient for them, they can go ahead and they can issue tokens. And so what we can actually write here is a for loop. So a loop is something that can iterate through and make decisions based on what you imply, and you can create the parameters for the iteration itself. And we'll see what I mean by that in a moment. But essentially, we want to iterate through our array of stakers, and then we want to be rewarding our stakers that actually are staking, right? So we want to iterate through that and then reward based off of that. So we do that with a for loop. And if you're new to JavaScript, you're new to Solidity, it might look a little bit weird to see. It might be a little bit confusing at first to look at these for loops. But really, it's just a syntax that you kind of get used to, and then you see it so many times, and it's really not a big deal. But at first, it may seem confusing for sure. So just like with JavaScript, what you do is you type in for, and the only difference here is that we have to remember that it's static for Solidity, so we have to write uint. So we're going to say I equals 0. And so this is our starting point. So I starts at 0. Our first iteration's at 0. I should be less than stakers.length. That's our array, right? So this is the point at which we stop our iteration. We go all the way through until the full length of I.stakers. And then what do we do after each iteration? Well, we can add another one to I. So we can say I++. Okay, so this is really a standard setup for a for loop, but you get used to it. If you're new to this, and it may seem a little bit weird. And what we want to do is we want to say that for our recipients here, we do stakers I, and our recipient's going to be address, right? So address, recipients. So each iteration of stakers is going to go to this recipient, okay, which is going to be an address. All right. So that's how we're going to keep track of each address. And we're also going to create an integer, call it balance. And here we can say it's going to be the staking balance. Staking balance of the recipient. Okay. So we create balance, and then we set, so we create balance as an integer, and we set it to our staking balance of each recipient. And we set our balance to the staking balance of recipient. So essentially we're saying that how much do we reward them in our balance? Well, the reward is going to be whatever it is, whatever was the amount that they were staking. That's what this is. So the staking balance of the recipient, the amount that the recipient is staking is going to be the balance that we return to them. Okay. And finally, we can transfer the tokens by running the transfer function from our WD, right? Because we want to be sending them reward tokens. So reward, and we're going to send it to the recipient. And what is the amount? It's going to be the balance, right? Isn't that beautiful at the end there? We take the recipients, the stakers, right? And then we reward transfer the recipients and then for the amount, all in a loop. Very nicely done. Again, we're just reverse engineering what Greg wrote, but hopefully we're going through it step by step so you can really see the process here. It's pretty standard stuff, but very useful to learn, and to learn it like this, in my opinion. Finally, something that we can add is to ensure that the transfer happens only if the balance is greater than 0. We can write an if statement. We can say balance has to be greater than 0. Okay, and then we can make this transfer happen only if the balance is greater than 0, like this. And there it is. That essentially is our rewards functionality to issue rewards. So let's go over it again. So basically what we're doing here is that we create a function called issue tokens, which we can then access with visibility, which we can then access publicly. Then essentially we make it so that only the owner can call this, right? Because we only want the owner to issue tokens. And how do we actually go about the logic of iterating and issuing these tokens? Well, we make a for loop, and we set the loop to basically all the stakers in the array, and then we loop through it. Now, as we loop through it, we send a as we loop through it, we create we create recipients that go to an address, and they each take an I. All right, they all take an I. Then we set essentially a balance to the staking balance of the recipient, so the amount that they are staking. And finally, we say that if the balance is greater than 0, we're going to reward them what that is, and we use the transfer, and essentially we transfer to the recipient the balance. We transfer to that recipient of the stakers the balance. Now, what if I wanted to create an incentive here? Well, let's say I don't want to give them that many tokens for starters. Let's say I'm like, well, I don't want to give them the equal amount of tokens, because this means that if they're going to stake 50 tokens, then they're going to get back 50 reward tokens. If they stake 40 tether tokens, they get back 40. All right, and so on and so forth. Well, what if I only want to give them 1/9 of that amount? No matter what it is that they stake, they only get 1/9 of that amount. Well, what we could do is we could actually, well, what would that do? Well, that would mean that if they were to stake 20 tokens, then they would only get, instead of 20 tokens, 2.2 tokens. I just calculated that on a calculator. If they staked 100 tokens, they would get like 11 tokens or something like that. So the more they stake, the more they're going to get back. So that's a nice incentive. So we're going to go ahead and say divided by 9. Okay, so we're going to save that, and now we've created our incentive, and we can even say divide by 9 to create incentive for stakers. All right, to create percentage incentive. All right, okay. So that's it then for the issue token. Let's go ahead and write some tests now to make sure that our issue token function is good. But actually, wait a minute. Before we do that, let's first just compile this down. Let's just compile this down. I know. I get excited. I want to rush. I want to rush to the next thing. But I don't want to leave you stuck. I don't want to leave us stuck like last time trying to solve the Truffle compile when we're already testing. So I'm just going to do a Truffle compile now. And let's see what happens. Okay, great. So it says that it's compiled successfully. Good news. All right, so let's move over into our tests and write the tests that we need. So the first thing we want to do is just check that we can issue tokens here from the owner. So in order to do this, it could be a simple test. We can just say await, and we're going to go to central bank issue tokens. We're going to grab that function, and we're going to say we want it from the owner. Okay, so that's going to run to check to see that this function we can issue the tokens from the owner. And then the other thing we should check is to make sure that only the owner can issue the tokens. So to do that, I'm just going to copy paste this. Here, let's bring that back. And ensure only the owner. I don't know why I'm putting this all in caps. Only the owner. You don't, these are comments. You can just comment how you want. I don't know. I guess I've been doing this so that they're like titles, but usually you just write out sentences, right? Ensure only the owner can issue tokens. And so that means that if I were to switch this from the owner to the customer is not allowed to issue tokens, right? That would be bad news. So what would happen if I switched this to the customer? Well, then it should be rejected, and we can actually test this by using our should. So we should say should be rejected. We can type it in like that. So there it is. There's our .should coming in handy. Let's put a semicolon. And let's save this and go ahead and run the test and see if it works. So we're going to go into our Truffle and type in Truffle test. Sorry, we're going to go into our console and type in Truffle test. Enter. Yeah, so the caller must be the owner. Okay, so if we go back in our code into our Decentralized bank, we're going to see here that in my constructor, I don't actually set the Decentralized bank. I don't actually set owner to the message sender, right? That's where we want it to be. So what we're going to do. So what we're going to do is we're going to add owner equals msg.sender. Okay. So I'm going to save that. And now when we require it to be it should be able to recognize in our test that the owner, that it's okay to receive this from the owner. So let's go ahead and run the test again. So back in the console, Truffle test. Okay, and now everything is passing. Excellent. So there we go. That actually would conclude our test for now for our issue tokens and for building out the functionality for issuing tokens. The only thing we really have left now is to do our unstaking, right? So we're able to stake and we're able to issue, but our customers or our investors aren't able to unstake. So let's go ahead and set that up in the next video, run the test for that, and after that, it's time to build out the application on the front end and hook all this functionality up so that it's user friendly and anyone can go on and with a click of a button start depositing their mock tether into our account. All right, that's exciting. Okay, that sounds pretty exciting. Great work. See you in the next video. Okay, wow, can you feel it? We are getting pretty close here. I am definitely getting excited about this. So let's now take a look at what we need to do. So we've done the staking function and the issue function. Right now we're in our Decentralized bank Solidity contract, right? And so the last function that we want to create here in our smart contract is going to be the unstaking, right? So right now our customer can come to our bank and deposit a certain amount of money and then withdraw that amount, tokens, and withdraw the tokens. And then in exchange, we can check to see what that amount is and then automatically send an amount of a percentage back on some type of schedule. And that's with our issue and our staking. But we also want to give another feature for our customers to be able to unstake, to be able to take it back. Let's write this underneath our staking function. So we can put some comments and write unstake tokens. Okay. And let's go ahead and write a function for that. So function, we'll call it unstake tokens. And it's going to be public. And we're going to create an integer here. So we're going to call it balance. We're going to set our staking balance to the message.sender. So already we're setting it up so that the amount of the balance right now is going to be the amount coming from the person who is calling upon the contract. So that's going to be that amount from the staking balance. That's important. We're also going to have to require that the amount is greater than 0, right? That makes sense. We don't want people unstaking anything less than 0. That just doesn't make sense. Require the balance to be greater than 0. Staking balance can't be less than 0. Okay. And actually, this isn't going to read right. We should put this underneath. So we're going to do that. So uint balance equals staking balance array for the message sender. And we require that the balance is greater than 0. Okay. So we can even comment require the amount to be greater than 0. Just right. All right, so after this, we want to transfer the tokens to the specified contract address from our bank, right? That's essentially what we want to happen here. We want whatever that amount that they've been staking to be unstaked, sent back to them from our address back to their address. So how would we write this? Go ahead and give it a shot. See if you can actually come up with the logic yourself. All right, so hopefully you had some success. If you didn't, don't worry about it. We're going to go ahead and give it a shot together. So basically, we want it to be the tether to be we want tether to be transferred back, right? So we can call the transfer function from tether. And remember that transfer takes the amount and it takes the address, right? So what's the address where we want to send it to? Well, it's going to be the message.sender. And what's the amount going to be in this case? Well, in this case, it can just be the balance, right? Pretty awesome. And if you got that right, awesome job. Okay, so now we're doing the transfer. We're requiring that it's over 0. What other logic should we be adding towards this unstake function? Well, if they're unstaking all their tokens, then we need to update the staking balance in our app, right? They can't still have tokens there after they take it back. And we need to tell our function to do this. Otherwise, they can just continue to do this over and over, and our application will not be the wiser. And how would you do that? Well, you can just say staking balance of the message.sender should be equal to 0. And finally, we want to update our staking status. Remember, we have our staking status here. So is staking is essentially what we want to be updating. So we can say is staking msg.sender is going to equal false, right? Okay, and so that's it for our unstaking function. So let's go ahead and compile this and see that it's working. So go to the console and just run a compile. Okay, so we've compiled successfully. Awesome. So we haven't made any mistakes in here from what we can tell. But let's go ahead and now write some tests to make sure that the functionality makes sense and is working the way that we would expect it to. Okay, and we can run our tests. We can and we can run our unstaking tests, and we can write these unstaking token tests back in our test, right, in our Decentralized bank tests over here. Nope. Yes. Wait. Oh, I was confused. There's too many tabs. Let me just close this tab. We don't need the JSON. Okay, excellent. So back in our decentralbank.test.js, hopefully you're getting the hang now of writing these tests a bit. The first test that we want to write here is just to check that we've unstaked the tokens. So we can do unstake. And it's very similar to our issue tokens, but we're going to use the unstake, and we want to see it from the customer, right? So I can actually just copy this. Wait, and this is going to be unstake tokens from customer. All right, and that's it. That's really it to check, because what is this going to do? It's basically going to go back to our Decentralized bank contract. It's going to check the unstake function, the unstake tokens function, and make sure it's coming from the customer. Okay, so that's going to make sure that it comes from the customer. Now, what other kind of tests can we write for unstaking? Well, we can actually write some tests thinking ahead, right? Like if we think in advance, well, what would happen after we unstake? Well, after we unstake, for example, the application, there should be 100 tokens now returned back to our customer, right? Because they're technically going to be unstaking everything, right? We're just going to have a button that unstakes it all. So we can write a test to check that. So why don't we say check unstaking balances. And we can actually run a very similar tests like we did with the staking, only the logic just needs to, be copacetic with unstaking, right? So if we scroll back up, we have some tests over here, and I can just copy these over like this, and we can rewrite them together. So unstaking balance. So the first one here, result equals await, tester customer. So after we unstake, instead of having 0 tokens for the customer, we should actually have how many? We should have everything back, right? So we should have 100. And we can rewrite this here, customer walk balance, after unstaking, right? And I can remove this 100 tokens like that. Okay. And we can check the updated balance. Okay, and then we could go to the unstaking, and we could go to the is staking update. It should be is staking update better than that. And you know what? I'm going to write this here, is staking balance. I'm going to change it to is staking update because this is Booleans for true or false values. And here, essentially, we should no longer be staking. So what should we change here? Well, the equality should not be true anymore, right? So we're going to switch it to false. Customer is no longer staking after unstaking. And then how much, and then finally, what should be the updated balance of our Decentralized bank after they take back their 100? Well, we no longer have 100, so this is going to be 0. And that's it. All right, that's a complete test suite. That's everything. We've basically covered our staking, unstaking, staking updates, issuing tokens, our 3 functions, our main 3 functions in our Decentralized bank smart contract here of unstaking, rewarding, issuing tokens, and depositing tokens, staking our tokens. So let's just do the good old save, and let's open up our console and run a Truffle test. Let's see what happens when we run this test. Enter. And everything is passing. Ugh, amazing. All the tests are passing. That's it. We did it. This is a full test suite that's been completed. And not only that, we've actually completed all of the important functionality for our smart contract. For everything in our smart contract, we've checked out all for the staking. Not only that, we've actually written out everything, all the functionality for our unstaking, for our staking. So congratulations getting this far. This is no small feat. We've gone through writing the functionality to looking at line by line, code by code, what everything means and how they're connected with each other. So in the next video, we're going to write our final script so that we can actually issue reward tokens to our customers, and we're going to have a script where we can just run the script on Truffle and do it like that. And after that comes the actual front end functionality and the fun stuff for building this out onto our UI. So great work. Have a coffee break or something. You've come really far, and I'll see you in the next video. Bye-bye. All right, so let's write out a script that we can use in our Truffle terminal, which essentially can just issue the tokens. So that way we don't have to write out a function every single time that we want to issue tokens. We can just call our script, and whenever we call this script, then our tokens get rewarded. Our tokens get rewarded. We can reward our tokens to those customers who are staking, and that's something that we do on our schedule, remember? And the script will follow all the protocols and everything that we wrote, right? It will only work it will only issue the tokens when they are actually staking, and it will follow the code that we set up in our issue tokens function accordingly. So we're just going to be running it essentially, and as the owner we can decide how we want to be running it, when we want to be running it. So the first thing we want to do is we want to go back to our DeFi staking app in the directory. We want to make a new directory from there. So mkdir space, and we want to call it script. And now let's cd into scripts. And here we're going to make a new JS file for our for issuing the tokens. So we can just say touch issue tokens .js. We just go to back to our text editor, and we should see scripts over here. And here's our issue tokens file. Okay, awesome. And I can see already that I misspelled issue. So I'm going to just rename that issue to issue. Even better. Okay, so the first thing we want to bring in here is going to be our Decentralized bank. And hopefully you're familiar with this by now. Artifacts.require central bank. And what we're going to do, just straight up, we're just going to export this function right away. And we can do that by just passing the function into our module export. So we can just do module.exports like that. And we're going to make an async function. So async function issue rewards. Okay. And in here, we're going to bring in our Decentralized bank. So we can say let Decentralized bank equal Decentralized bank dot deployed. And what am I missing here? You probably guessed it by now, the await, right? Otherwise it's going to skip right through. And now we're going to actually await the Decentralized bank dot issue token issue tokens, right? Because that's what we want. Okay. And then we're going to console.log tokens have been issued successfully. And this is going to be a callback function. And what's a callback function? Well, it's a function that just kind of calls itself. So we can just put as our argument callback like this, and then we can actually call it. So we can do that by just putting in callback here and calling it. Okay, awesome. And so that's essentially what we need for our script. We need for our script so that we can actually call and reward tokens from the terminal. Okay, because that's what we're going to do it from the terminal. And let's just take a look quickly. So we created an async function here called issue rewards. So this is what we're going to be calling. And within that, we just take our Decentralized bank. We take our Decentralized bank contract. We grab the issue and we await to call the issue tokens. So we actually call issue tokens from our, where is it? Contracts. From our contract over here. Issue token here, right? Function issue token. So we're going to basically execute this command whenever we call this function. Where is it? Whenever we execute the function in our scripts, which is in our scripts over here. Okay, I'm kind of getting lost in my own thoughts. So now that we have this, why don't we run the script and see if it runs and we get this console. So we're going to go to our terminal over here, and the first thing we want to do is let's just run a migrate reset. So we're going to do truffle migrate -- reset. So let's make the updates happen. Okay, so we've ran the updates, and now let me cd back to the DeFi staking app. And now to run the scripts, all we have to do is use the truffle exec command. And you can go to the Truffle website to look at all the truffle commands on the terminal. But this will just execute scripts, right? So we can say truffle exec scripts, because that's the file folder, and it was called issue tokens, issue-tokens.js. Okay, and now let's run this and see what happens. And it looks like I made a mistake. I did not, it looks like over here I didn't spell artifacts correctly. Maybe you guys saw that. Let me take a look. I was too excited. Artifacts. I just like cats. What can I say? Artifacts. Okay. Save and let's run it again. Okay, and there's another mistake here. It seems like the central bank is not defined, but it should be. So let me go back in again. Okay, so first of all, I see some mistakes here. The decentral bank.deployed should be coming from our decentral bank. So this should actually be coming in from here. And this way it should actually detect it when I switch it to decentral bank. Yeah, so these should have been capitalized, first of all. And second of all, well, I don't think there is a second of all. I think that's it. So let's go ahead and run it again. So we're running Truffle exec scripts / issue -tokens.js, right? It's right over here. And third time is a charm. So hopefully this time we go green. Go green or go home. And there we go. I don't know if you see it, but we can see it right over there. I'll make it larger because it's so successful. It's so exciting. Tokens have been issued successfully. All right. So actually, the reality is that no tokens were issued, right? Because nobody deposited anything. But we just ran the console log just to see that the script works. So the real test will be once we have the website working and people stake, and then we're going to run it to see that it actually issues the tokens over. But just to get the console.log, that's a great green flag. Good test. It passed. Excellent. Okay, and that ends this section on building out our test suites. Congratulations for getting to the end. If you're having errors, you're having some problems, go back, see where the errors are. You can ask somebody in the community or go to my GitHub and get the final solution, copy it down, and check it that way. But great work getting this far. And next up, when you're ready and we're ready to go ahead, the next section, we're actually going to build out the front end. So we're going to develop the application. We're going to build out a nav bar. We're going to build out a loading bar to make sure things are working, and then staking and unstaking buttons. And we're even going to build out an airdrop timer for us. So we're gonna work in React, and we're gonna see how React works with blockchain and how we can take the blockchain smart contracts and implement them, leverage our Web3, MetaMask, and actually integrate all this together. So it's the coming together of all the things. You made it this far. You deserve a celebratory high five. Take a break or something. And when you're ready, I'll see you in the next video. Okay, bye for now.